Hello guys, I will continue with chapter 6, input-output streams. We left off at around slide 48. We're talking about the flags. So these are the ones that are used in the magic formula. Let me refresh your memory about the magic formula for formatting the output. And there's a selection of flags that you can set. For example, the first one is for fixed notation. We have scientific notation to show the decimal point, to show a plus sign before the positive integers, to align to the right and to align to the left. Okay, so the right one, it says, if you see under default, it says set. That means that because this is the default output. Okay, so how do these last two work? Okay, so let's say that you want to organize your output, let's say in columns. Okay, so you need to call the member function width. Okay, so this one right here. Okay, and let's say that I set the width to 4 places. Okay, so and in these 4 places I want to output a 7. Okay, so that means that I'm using 1 space and 3 of them are blank. If I align to the right, this is how it's gonna look like. The 7, it's going to be to the right, and then before that there's going to be 3 blank spaces. And if you want to align to the left, okay, so you're gonna have the 7 first and then the 3 blank spaces. Okay, what happens if, and this is another member function, remember. So what happens if the space I specify is smaller than the number I want to print? Let's say I specify 3 spaces, okay, but I want to print 7. Okay, so don't worry about that. The whole number, the entire number, the 3,456.45 is going to be outputted. The only thing is that maybe your output is going to become a little bit disorganized, but it's going to output the entire thing. And what happens if, let's say that you set the flags for the positive or the plus sign. If you wanna, after a certain point in your program, you want to stop printing the plus signs, okay, you just go ahead and unset the flag. So you call another member function, unset flags, and you specify that this is a flag that you want to stop using. Okay, we have something called manipulators. I'm not sure if this is the right word, but I see manipulators as shortcuts, okay, to some of the member functions. Here's the first one. The first one is called setw, and this is equivalent to member function width. Okay, so these manipulators, you use them in the insertion operator. So they're like more, let's say, direct. Okay, so notice how you set it right in the cout in between the manipulators or the carets. Here you are outputting start, so this would be your output start. Then you set 4 spaces. So let's assume that you have 1, 2, and all the way over here is 4 spaces in total. So the 0 and the 1 occupy 1 space each. So that means that here you have 2 spaces blank. Then I'm setting 4 more. So all of these are 4 spaces. So you have 1 for the 0, 1 for the 2, and then you would have 2 remaining spaces. And then the last one, you are setting 6. So all of these are 6. You have 1, 2, and then 4 blank spaces here. Okay, so that's how this would work. We also have an equivalent manipulator for precision, and this is called setprecision. Okay, so let's say that if you want to use it in your magic formula, all you have to do is put the setprecision at the end with the cout, so no member function here, and this would make both the 10.3 and the 20.5 display 2 decimals after the point. And this will remain in effect until you change it. So let's say that after this you want to output 3 decimals. So you would need to cout this one again, but now with a 3. If you want to use any of these manipulators, don't forget to include this directive at the beginning of your program, the input output manip. Okay. Okay, another thing is regarding to functions. So yes, you can use files, or here we call them streams, input or output as arguments to your function. But notice that they must be called by reference. So in the parameters, you must include the ampersands. So this would be for the input file stream, and the need file would be for the output stream. Okay. Now, what happens if you want to read all of the information in the file until you reach the end? Okay, so let's recall, let me go back to slide 38. Okay, this sample code that we tested in class. Okay, so here you have an input and output file, and in this part right here, the very top, you declare 3 variables, first, second, and third, and then you read with an in stream. So this is equivalent to your cin. You are reading the first, and we had numbers, so here you have 1 through 4. So here you're only reading the first one, which is 1, the second one, which is 2, and the third one, which is 3. And then I showed you that if we wanted to read all 4 of them, that you had to declare a 4th variable and also add it to the in stream where you're reading it. Okay, but what if you have a file with 100 numbers? You're not going to create 100 of these variables. So the way to do this, if you want to read all of them, would be with this code right here in red. So you would use this Boolean expression, you're going to put it in a loop, okay, and this is what it does. So that means that you are reading from an input file, and whatever piece of data, let's say number, that you have next is going to be stored in a variable called next. Okay, so this here is going to be true if there is something to read. So if there's a next number, it's going to be true. However, whenever you don't have a number coming up next, this is going to become false and it's going to get out of the loop. Okay, and this is an example on how this code would be applied, but I am going to make a little demonstration here. Okay, so here, what's the same code from the slide, and what we're trying to do here is we're going to add all of the numbers in a file, and then we're going to compute the average. Okay, so let's say that we have a file, this is our file, and we have 1, 2, and 3. So this is our file. Please excuse my handwriting. This is in stream. Okay, let me change colors. Okay, so you have next. Okay, this is the number that you are reading. Then sum equal to 0, initialized to 0, and count initialized to 0 as well. Okay, so we have while in stream, so you check in stream, next. Okay, what are you reading next? So you are reading 1. So right here, next is 1. The sum is going to be equal to sum, right now we initialize it to 0, so it's going to be 0 plus 1. Okay, so right now sum is equal to 1. And then we add 1 to count, which was initially 0, so count is 1. Then it's going to go to the beginning of the while. In stream, checks in stream, next. Do you have a next number? Okay, so now we have, let me change colors. Let's say now we have 2. Okay, so now next is going to be 2. Okay, so it goes to the sum. Sum is now equal to 1, so it's going to be 1 plus 2. So now sum is 3. And you add 1 more to count, so now count is equal to 2. Then it goes back to the while. Okay, in stream, is there a next number? Okay, let me change colors. Okay, so now my next number is 3. So I read 3 and I store it in next. For the sum, Okay, so sum was equal to, I'm going to put it here, 3 plus the 3 that I'm reading. So now sum is equal to 6. I add 1 to count. Now count is 3. Goes back to the while. Is there a next number? Okay, so no, there is no next number. So this in stream next becomes false. Okay, so it's going to get out of the loop and it's going to go here. And here sum, okay, was equal to 6 divided by count, which was 3. So the answer is going to be 2. Okay, so this is how that code works. Okay, now continuing with the presentation. Okay, so I have a sample code that I want to go over using all of the things that we've learned so far. So this sample code, it's going to write output to the screen and to a file. So yes, you can output both to the screen and to the file at the same time. We're going to be using the formatting instructions because we want to create a neater layout. We're going to be writing the numbers 1 per line, and we're going to give a field width of 12. We're going to have 5 digits after the decimal point, and we're going to add plus signs to all of the positive integers, or well, positive numbers, because I don't think they're all integers. Okay, so if you guys can go ahead and open source code 0606, okay, which is this one. These are all of the directives that you need to include if you're using manipulators, the standard library, file stream, and input-output stream. You have a function here. Okay, so you have an input file and an output file as arguments. Don't forget to include the ampersands because these must be called by reference. Then you have the number after the decimal point and the width of the field. Yes. Okay, you already know the first part. You declare your file input, your file output. You open, you test. Okay, all the same thing for the output file. You open, you test. I changed the extensions to text on both of them, and I added the system pauses here and at the end of the program. After doing all of this, you call the function. Okay, so let's go to the function. Okay, so you have the same, this is the header, the same as your declaration up here. Okay, so what you're passing here for the input file, okay, you are passing a messy file. So in the call, you have fin. So this argument goes to this parameter right here. And fin is connected to a file called raw data. Then for the output one, okay, you are passing argument fout. And fout is connected to neat.txt. It's another file. Then you have the numbers after the decimal point. We said they're going to be 5. And the length of the field would be, the width of the field is going to be 12. So this would be the second one. Okay, so here I added some comments. Because this first part, okay, notice that all of the flags and the precision, all of these member functions, are, you can say, connected to neat file. So that means that they're connected to the output file. So all of this is for formatting purposes of the output file only. But in the instructions, it says that we also want to output it to the screen. So if you also want to format the output to the screen, you have to set all of these flags and this precision to the cout, because the cout is the one that goes to the screen and neat file goes to the output file. Okay, that's just pure formatting. Then we see this code again. So you have messy file, that's the input file that you're reading from, and you want to know if there's a value coming up next. Let me show you what the file looks like. So you have all of these numbers disorganized. You want to set one number per line, align them, have 5 decimal points, and positive signs at the beginning of the positive numbers. So what you're doing here is, this is cout, so this one goes to the screen. That's why I put a comment here for screen. You're setting the width, and you're reading the number that's coming up next. I mean, you're outputting the number that's coming up next, and you also output a new line. So that means that the next number that is read, it's going to go to the next line. Same thing to the one that it's going to the output file. That's why I added the comment for the output file. You're setting the width, then you output the number, and you output an end line. Okay, so you're going to continue doing this until it reaches the last number, which is that one right there. So you have, let me go back to the formatting. You have fixed notation, because notice that one of the numbers here, it's in scientific. You also want to show the decimal point. You want to show positives, okay? And then you set the precision to 5. Okay, so now if we run this program, okay, notice that the output to the screen, okay, so it looks all aligned. It has the positives, the 5 decimals, etc. But this is just to the screen. Now we have to look for the file that contains this as well. So it created neat.txt, and this is what neat.txt looks like. So it's the same as the one that you see in your screen. Okay, so it had output both to the screen and to a file. Then continuing with the presentation. Okay, so this is exactly what we just did. This is the output. And the conclusion, so show the output produced when the following line is executed. Okay, so let me change colors. Okay, so it's outputting a star, and then even though it's setting the width to 3, okay, and you have a number that occupies 5 spaces, it's still going to output 1, 2, 3, 4, 5, and then the closing star at the end. Oh, sorry. Here. Okay, so it doesn't matter if you set it for less spaces, it still outputs the entire thing. And then slide 64, the second question for the conclusion. The effect of all of these flags, I'm not going to describe all of them, but you can refer back to slide 48. Okay, so you have 1, 2, 3, 4, 6 flags. Okay, so I'm going to put refer to slide 648. Okay, so refer to slide 648. Okay, and this would be the end of section 2. I will continue with the rest in the next video.